मॉर्निंग फिफ्थ क्लास। हाउ आर यू बेटा? आई एम फाइन। आप कैसे हैं? हमने चैप्टर 1 स्टार्ट किया था आपका, उसमें आपके ट्रायंगल्स के बारे में था, एंगल्स के बारे में था। तो आज हम उस चैप्टर को, उससे रिलेटेड कुछ चीज़ें हैं जो इसमें डीजी में डिस्कस करेंगे। ओके स्टूडेंट्स, लेट्स स्टार्ट। बेसिक कंसेप्ट और ज्योमेट्री के बारे में पढ़ेंगे बेटा हम।
We live in a world that is made up of shapes. The sun and the earth have a shape. The mountains, the rivers, the trees, the flowers have shapes. The moon and the stars have shapes. We use so many different objects. The pencil and the paper to write with, the chair and the table to sit, the ball to play with. All these have shapes as well. The study of these different shapes is called geometry. Did you know that the word geometry is derived from the Greek word geometron? Geo means earth and metron means measurement. What do you get when the tip of your pen touches the paper? Right? In geometry, a dot is called a point. A point has no size. It cannot be measured. Hence, we say that a point is dimensionless. A point can also be obtained by pressing the tip of a compass or the pointed end of a needle. All these three are points. But how do we distinguish between these points? Simple. We name them. Single capital letters are used to name points. The letters are written next to the points. This is point A, this is point B, and this is point C. A point is used to denote a position or a location. Here are some real-life examples where points are used to indicate a location or a position. Marking major cities of a country, locating a constellation in the sky, identifying fielding positions on a cricket field. Coming back to our points, imagine points A and B are two cities and you want to travel from one to the other. What would be the shortest route of travel? This, or this? The straight route would be the shortest. The straight and so shortest distance between 2 points is called a line segment. A line segment has no thickness, but it has a length. It is said to be one-dimensional. A line segment is denoted by its end points. This line segment has point A and point B as its endpoints. It can be referred to as line segment AB or line segment BA. The small bar above indicates that it is a line segment. Explore the scene. Can you see examples of a line segment? The thread, the edges of the ruler, of the box, of the photo frame, and of the window frame. These are all line segments. Let's get back to our line segment. If we extend it at both ends, we get a line. Just like a line segment, a line does not have a thickness. Its length cannot be measured as it is limitless. A line can be named by a lowercase letter like or by naming any 2 points on the line. This line can be called line or line AB or line BA. A small double-headed arrow above AB is also used to write a line. A line can be imagined to be a straight road with no start and no end. Now, here is a quick question. How many points are there on a line and a line segment? An infinite or a finite number? A line and a line segment both have infinite points. A line can be defined as a collection of infinite points. Now consider the part of the line that starts from point A. It is called a ray. A ray is a part of the line that has a starting point and no end point. It moves endlessly in one direction. A ray is named by its starting point and another point on its path. This ray can be called ray AP. It is denoted by drawing a single-headed arrow. Another quick question. Which of these figures are examples of rays? A flashlight, a laser beam, and sun rays are examples of rays. Another very important concept in geometry is that of a plane. Consider this sheet of paper. It has a flat surface. Now imagine its edges extend endlessly. When traveling, you may have often come across crossroads. A crossroad is the point where two roads cross each other. Let's represent the two roads by lines PQ and RS. Lines PQ and RS cut each other at point O. Two lines that meet at a point are called intersecting lines. on which a train runs? Do they ever meet? Let's draw two line segments AB and CD to represent the tracks. You can see that they do not meet at any point. Let's extend them in both directions. They still do not meet at any point. Lines that lie in the same plane and never meet are called non-intersecting or parallel lines. Similarly, you must have seen observe these objects. What do you see that they have in common? Observe these formations. Don't they represent two rays with a common starting point? Such formations are called angles. The two rays are called the arms of the angle, and the common point is called the vertex. Angles can be named by 3 points. 2 points lie on the same arms and the vertex. The first angle can be called angle ABC or angle CBA. The second angle can be called angle PQR or angle RQP. The third angle can be called angle XYZ or angle ZYX. An angle symbol is used to denote an angle. The vertex is always read as the middle letter. An angle can also be denoted by its vertex. These can be called angle B, angle Q, and angle Y respectively. Now, look at this figure. How many angles are formed here? There are 3 angles formed at the common vertex P. These angles are angle APC, angle APB, and angle BPC. Points to remember. Geometry is the study of shapes. A point, a line, and the plane are the fundamental building blocks of geometry. A point has no dimensions and denotes a position or a location. A line is formed when infinite points are joined. It has no thickness and it has an infinite length. A line segment is formed when 2 points are joined. It is straight and represents the shortest distance between 2 points. A ray has a starting point but no end point. It extends infinitely in one direction. A plane is a flat surface that extends indefinitely at all edges. It has no thickness. 2 lines that meet at a point are called intercepting lines. 2 lines that lie in the same plane and never meet each other are called parallel lines. An angle is formed when 2 rays have a common starting point.
ओके स्टूडेंट्स, तो ये था हमारे ज्योमेट्री से रिलेटेड। अब हम डिस्कस करेंगे कि एंगल्स को कैसे बनाया जाता है, उसकी मेजरमेंट कैसे की जाती है और प्रोटेक्टर डी का यूज़ कैसे होता है।
Two rays with a common starting point form an angle. You see angles in all walks of life. These angles can be of many types. Let's look at some basic types of angles and the methods to measure them. Let's begin with one of the most common angles that we see, the right angle. Why is it called a right angle? Try this activity and you'll see why. You are already familiar with directions: east, west, north, and south. Here is a big compass. Suppose you are standing at the center facing north. What would you do if you needed to turn east? Turn right or take a right angles turn? Can you recall where else you have seen right angles around you? Here are a few examples. So, why are right angles important? Well, think about it. What would your world look like without right angles? Something like this, perhaps? But what happens when you join two right angles? Can you group these angles into right or straight angles? Difficult, right? Some seem bigger and others seem smaller than a right angle. There is an easy way to check whether an angle is a right angle or not, by using a right angle tester. You can create your own tester. Take a piece of paper and fold it as shown. Your right angle tester or RA tester is ready. Want to try it? Consider this kite. Line segments AB and AO make an angle. Let's check this angle. We place the RA tester at this corner. As you can see, the edges of the tester don't match with the corners of the kite. That means the lines on this corner do not form a right angle. But if not a right angle, what angle is this? Well, let's see. The angle we just measured seems smaller than a right angle. That is, it seems to be less than 1/4 of a revolution. Such an angle, smaller than a right angle, is called an acute angle. Here are some more examples of acute angles. Which of these angles are acute angles? And how about this angle? Shall we try the RA tester on it? It sees more than 1/4 of a revolution, but less than half a revolution. That is, it is larger than a right angle, but smaller than a straight angle. Such an angle is called an obtuse angle. Here are some more examples of obtuse angles. Can you make out what type of angles these are?
जो 90 डिग्री से कम होते हैं उन्हें एक्यूट एंगल कहा जाता है, जो 90 डिग्री से ज़्यादा होते हैं उन्हें ऑब्ट्यूज एंगल्स कहा जाता है।
You know the difference between acute and obtuse angles by now. Let's go one step further. Which of these acute angles is bigger and how much bigger is it? To answer this question, you need an exact measure of each angle. An angle is measured in degrees. One complete revolution is said to be 360 degrees. So, if you divide a complete angle into 360 parts, each part will be a degree. With this knowledge, let's go back to the exercise we did with a compass. If a complete angle is 360 degrees, how many right angle turns are required to make a 360 degree angle? In a rotation, a right angle corresponds to a quarter turn or 1/4 of a turn.
यूजिंग ए प्रोटेक्टर डी का प्रयोग कैसे करते हैं देखिए आप।
We already know that the amount of turn between two arms or two ways that have a common endpoint is an angle. Just as we use a ruler or scale to measure length, we use a protractor to measure angles. The protractor also helps us construct angles. There are two types of protractor. One is circular in shape and therefore called circular protractor. However, since it is difficult to carry and use the circular protractor, most people now use a more convenient half-circle protractor. The unit for measuring angles is degrees. Let us take some time to understand what are degrees. The shape drawn by the strip after a complete turn is a circle. A circle can be divided into 360 equal parts. The angle between each part is called 1 degree. in a half circle is 180 degrees. A special symbol. Let us start by measuring angle ABC. Place the center mark of the protractor at the vertex of the angle, which is represented by point B. The zero edge must be in line with line BC. As this angle opens to the right side, we must use the lower row of numbers. Start to read from 0 of the lower row. Read the number in the lower row where the arm BA meets the protractor. It shows 20. So the angle ABC is 20 degrees. This is an acute angle as it is less than 90 degrees. Now let us find the angle DEF. Place the center mark of the protractor at the vertex of the angle, represented by point E. The zero edge must be in line with ED. As this angle opens to the left side, we use the top row. Start to read from 0 of the top row markings. Read the number in the top row where the arm EF meets the protractor. It shows 110. So, the angle DEF is 110 degrees. This is an obtuse angle as it is greater than 90 degrees. When an angle measures 90 degrees, it is called as right angle. Let us now look at some more angles and try to measure them. First, let us find the angle GHI. Place the center mark of the protractor at the vertex of the angle that is represented by point H. The zero edge must be in line with HG. As this angle opens to the right side, we must use the lower row. Start to read from 0 of the lower row markings. Read the number in the lower row where the arm HI meets the protractor. It shows 30. So the angle GHI is 30 degrees. This is an acute angle as it is lesser than 90 degrees. Now let us find angle XYZ. Place the center mark of the protractor at the vertex of the angle represented by point Y. The zero edge must be in line with YZ. As this angle opens to the left side, we use the top row. Start to read from 0 of the top row markings. Read the number in the top row where the arm YX meets the protractor. It shows 140. So, the angle XYZ is 140 degrees. There is also another way of measuring this angle. Instead of keeping the zero edge of the protractor on YZ, we can also keep it on YX. And therefore, we must use the numbers on the lower row to read the measure of the angle. Read the number in the lower row where the arm YZ meets the protractor. It shows 140. So, the angle XYZ is 140 degrees. This is an obtuse angle, as it is greater than 90 degrees. Now let us find the angle PQR. Place the center mark of the protractor at the vertex of the angle represented by point Q. If we keep the zero edge of the protractor on QP, the angle opens to the right side, and therefore we must use the lower row. Read the number
where the arc QR meets the protractor. It shows 60. We can also keep the zero edge of the protractor on QR. Then the angle opens to the left side and therefore we must use the top row. Read the number in the top row where the arc QB meets the protractor. It shows 60. So, the angle PQR is 60 degrees. This is an acute angle as it is lesser than 90 degrees. Identify the correct scale that must be used to measure the angle. The center mark must be placed on the vertex of the angle. The zero edge must be in line with one arm of the angle.
ओके स्टूडेंट्स, तो ये था हमारा चैप्टर इन डिजी। आपको एंगल्स बनाने सिखाए हैं मैंने। तो 90 डिग्री से जो कम होता है उसे एक्यूट एंगल, जो 90 डिग्री का एंगल होता है उसे राइट एंगल, और जो 90 डिग्री से ज़्यादा होता है उसे ऑब्ट्यूज एंगल, और जो 180 डिग्री का आता है उसे स्ट्रेट एंगल कहा जाता है। ओके स्टूडेंट्स, स्टे होम, स्टे सेफ।